This is section 1.4, which is equations of lines and modeling. And we're going to be focused on making sure we know how to identify the slope and the y-intercept when something is given to us in slope-intercept form, which is our y equals mx plus b. That's how we like it to be written, right? We're also going to look at using the point slope formula, which is y minus y1 is equal to m times x minus x1. We'll talk about that in a minute. Both of these forms you're going to be responsible for knowing, okay? And then we're going to look at the relationship between lines that are parallel and lines that are perpendicular and how we can use that to find the slope of a given line in order to use it to find the slope of the line we're trying to find, okay? So first of all, slope-intercept form looks like y equals mx plus b, where m is our slope, right? And b is our y-intercept, which we write as an ordered pair because it represents a point on the graph, okay? So ideally, if we're given something in slope-intercept form, we should be able to identify the slope and the y-intercept. So if you look at this first example, it says, find the equation of the line given the information about the line. Notice here they gave us the slope and they gave us the y-intercept. So if we know the slope and the y-intercept, we should be able to write it in y equals mx plus b form, right? So it would just be y equals negative 3/8 y plus 6. We just put, oh my gosh, not y, x. I saw the y right above there and I just thought I'd write it in my brain. 3/8 x plus 6. Sorry about that. Okay, so we can always just plug it straight into slope-intercept form as long as we know the slope and we know the y-intercept. Now it's very, very rare that they're actually going to give us the two things that we need. And so when they don't give us the two things that we need, sometimes they'll give us the slope, but usually the point that they give us is not the y-intercept where we can easily just plug it in. So if they give us a point other than the y-intercept, then we're going to use this point slope formula that says if I have any point x1, y1 on my line, then I can plug it into this formula in order to work it out and make it look like this, okay? So I'm going to go ahead and work out the same one using this formula so that we can see we would get the same thing, okay? Just for practice. So we have y minus y1 is equal to m times x minus x1. And we're going to plug in the point that they gave us. So 0, 6, this is our x1, y1, right? And then our slope is negative 3/8. So we do y minus the y from the point that was given, which is 6, is equal to our slope, which was given, negative 3/8, times x minus the x of our point that was given, which is 0. Okay? And then we just simplify. So here I'm going to have y minus 6 is equal to, when I distribute here, negative 3/8 times x is negative 3/8 x, and then negative 3/8 times 0 is just 0, so I'm not going to write it. And then we move our 6 to the other side by adding. So notice, either way, we end up with y is equal to negative 3/8 x plus 6. So ideally, they will give us the slope and the y-intercept and we can just plug it directly in. But if they give us a point that isn't the y-intercept, then we have to use this point slope formula in order to get it in slope-intercept form, okay? So the other thing they might do is they may not give us the slope at all. They may leave it up to us to find the slope. And so if we need to find the slope, we have to use our slope formula that we went over in the last section, which is that m is equal to y2 minus y1 over x2 minus x1, right? Where we have 2 points. So on this one, notice they give us 2 points. So we first have to find the slope using those 2 points, and then we can use that slope and one of these points and plug it into our point slope formula, okay? So I'm just going to label these. This is x1, y1. This is x2, y2. And I'm going to plug it into our formula. So slope is equal to our second y, which is negative 5, minus our first y, which is 7, all over our second x, which here is negative 1, minus my first x, which is negative 3. When we subtract a negative, those double negatives become positive. So this becomes negative 12 over what? Negative 1 plus 3 gives me a positive 2. So that lets me know that my slope is negative 6. Okay, so now I know the slope, but in order to find the equation of the line in y equals mx plus b form, I have to know the slope and the y-intercept. So I have my slope, but notice neither of these lines are a y-intercept. So if neither of them are y-intercept, I can't just plug it directly into y equals mx plus b. I have to use my point slope formula. So to use the point slope formula, I need the slope, which I just figured out, and any point on the line. So I could use either of these. I try to use the ones with either the smallest numbers or the ones that has a 0 in it or the one that has the least amount of negatives in it. So I'm going to pick this one. If you choose the other one, you'll get the same answer when you work it out. Okay, so we're going to do y minus y1 is equal to m times x minus x1. So we do y minus the y that I chose, which here is 7, is equal to my slope, which we just found to be negative 6, times x minus the x that I chose, which here is negative 3. Okay. Again, my double negatives become positive, and then I can distribute this negative 6 into those quantities. So y minus 7 is equal to negative 6x minus 18. And then the last thing I have to do is move that 7 to the other side, which I do by adding. So this gives me y is equal to negative 6x minus 11. So this is the equation of the line through the two given points. Okay. So here the slope wasn't given to us. The only new step is that we had to use 2 points to first find the slope, and then we could use the slope and one of the given points in our point slope formula. Okay, let's look at another one. So if we look at this next one, again, the slope is not given. So we're going to start off by calculating the slope by doing y2 minus y1 over x2 minus x1. So if I plug my points in, this would be my x1, y1, x2, y2, right? So my second y, which is 1/2, minus my first y, which is 1/2. Oop, that should trigger something in our brains, right? Those are the same numbers. All over my second x, which is 1, minus my first x, which is 3. So notice what I'm ending up with is 0 over negative 2. So that means my slope is 0. Now only one kind of line has a 0 slope. We talked about this in the last section. Only horizontal lines have a 0 slope. So a horizontal line is a line that goes through a y value. So I could just look and notice right away that these have the same y value, right? The only way that can happen is two different points with the same y value is that it's on a straight horizontal line, and the line would have to go through y equals 1/2. So if you notice that right away, we can go ahead and just say the equation of this line is going to be y equals 1/2. If you don't notice that, that's okay. We can go ahead and work it out. So we know our slope is 0. Now we just need to pick one of these points. I'm just going to pick the second one. And we can plug it into y minus y1 is equal to m times x minus x1, our point slope formula. So we do y minus the y of the point that I chose, which is 1/2, is equal to our slope, which we just calculated down here to equal 0, times x minus the x value of that point, which is 1. Okay, so I end up with y minus 1/2 equals, notice if I distribute this 0 in, 0 times anything is 0. So this whole side just becomes 0, right? And then I need to move my 1/2 to the other side by adding. So I end up with y is equal to 1/2. Okay, so either way, we get the same answer. The only difference is, excuse me, sometimes it's easier to just notice that they go through the same value. And this would be the same true also if you had the same x value on both points. If you had the same x value on both points, then that would be going through a vertical line, right? Our vertical line slope is undefined, so we would have to know that it's an x equals some number type line. Okay. All right. So there is one on the next page for y'all to try. Go ahead and pause the video. And then whenever you are ready to check yourself, or if you get stuck, let me know and we'll go over it. Okay. All right, let's see how you did. So first thing we notice is that the slope was not given. And if the slope was not given, that means we have to calculate it. So we take the 2 points that were given to us and we plug them into our slope formula. So y2 minus y1 over x2 minus x1. We plug in our values, we should get 4 over negative 8, which reduces to negative 2. So that's our slope. Now that we have our slope, we're going to use that slope and one of the points. Now notice neither of these points are the y-intercept, unfortunately, so we can't just plug it straight into y equals mx plus b. So we're going to have to use the point slope formula. So now that we have our slope, I chose the first point because it has a 0, which makes things a little bit easier. And I plug it into y minus y1 is equal to m times x minus x1. So 7, 0 goes in for my x and my y1s, and then my slope of negative 1/2. When I distribute to simplify, I end up with y is equal to negative 1/2 x plus 7/2. Okay, hope we're all okay on that. We're going to go ahead and move on and now see how we can come up with this same process. This is the same process we're going to do on everything in this section. We're going to plug into y minus y1 equals m times x minus x1. Okay, so in order to use this formula, we need to know the slope and we need to know a point. 9 times out of 10, the point's always given. Pretty much, point's always given. Okay, but the slope will either be given to you or they'll give you 2 points so that you can find the slope, or they'll tell you something about your line and how it's related to another line. So that's what we're going to talk about now, is parallel and perpendicular lines and how their slopes are related. Okay, and then once we can use that information to figure out our slope, then again we're just going to plug it into the same formula and go over the same process we did on these problems. Okay, so let's look at parallel and perpendicular lines. Parallel lines are increasing or decreasing at the exact same rate. So they never touch, they never cross. If they're increasing or decreasing at the same rate of change, what that tells us about the slopes of parallel lines is that they are the same. Okay? When we talk about any line, we say that the slope is equal to m, right? We label it m. So if we talk about parallel lines, we use this little parallel line notation. That means the parallel slope. Okay? So the parallel slope is going to be the same as the regular slope. Okay? Perpendicular are specific lines that cross at a 90-degree angle, just like the x and the y axis on any rectangular coordinate system. Okay? Slopes of perpendicular lines are related in that they are opposite reciprocals of one another. Opposite reciprocals. Okay? So let's think about what that means. Opposite means I'm changing the sign. So if it's positive, I change it to negative. If it's negative, I change it to positive. Just changing the sign. Reciprocal means that I'm flipping it. So if I have the slope as some number over a number, if I want to do, the reciprocal, then that means I'm just flipping that slope upside down. So we're flipping it and changing the sign whenever it's perpendicular. And the way that we use our slope notation here is we show a 90-degree angle lines in front of our m. Okay? All right. So before we start using this to find the actual equation of a line, let's just see if we can identify if two lines are parallel, perpendicular, or neither using the comparison of their slope. Okay? Now in order to do that, we want to make sure each line is written as y equals mx plus b. Because if we have it written in slope-intercept form, we can easily see the slope. And then all we have to do is compare it. Are the slopes the same? Are the slopes opposite reciprocals? Or are they unrelated in any way? Okay? So let's look at this first example. Determining if these are parallel or not. If they're already written in y equals mx plus b form. So notice this one's slope is 3. And this one's slope is negative 1/3. So they're not the same. If they're not the same, we know they're not parallel. So then we look to see if they're opposite reciprocals. 3 could also be written as 3 over 1. So notice, if I were to take 3 over 1 and flip it upside down and change the sign, I would get negative 1/3. So because these slopes are opposite reciprocals, that means that these lines are perpendicular. Okay, makes sense? All right, let's look at one more. Same idea on this one, except this one, the two lines are not written in slope-intercept form. So the first thing I want to do is write them both in slope-intercept form so that I can compare their slopes. So I'm going to bring one over here, 2x minus 5y equals negative 3, and then I'll do that one next. Okay, so I want to solve this for y. So I'm going to move my 2x term to the other side by subtracting. So I'm left with negative 5y on the left-hand side, and on the right-hand side, I want it written with the x term first. So negative 2x minus 3, and then I just need to divide off my my negative 5. And when I divide that off both sides, what I'm really doing is dividing it off of every term. So that's going to leave me with y equals a positive 2/5 x plus 3/5. So I can see right here, this one's slope is 2/5. So in order for these lines to be parallel, the other line would have to have a slope of 2/5, or in order for them to be perpendicular, the other one's line would have to be negative 5/2, right? Because it would have to be flipped and negated. So those are the two things I'm looking for. So let's go ahead and solve this one. So we have 2x plus 5y is equal to 4. I want to get y by itself, so I move my 2x term to the other side. So that gives me 5y is equal to negative 2x plus 4. And then, oops, my paper's blowing away here. And then I divide off my 5. So I divide my 5 off of every term, and I get y is equal to negative 2/5 x plus 4/5. So this one's slope is negative 2/5. So notice my two slopes are not the same. So that means they're not parallel. And even though they're opposites, meaning I have one positive, one negative, they're not opposite reciprocals. So that means they're not perpendicular either. So that means they are neither. Neither, neither, neither. However we want to say that. Okay. All right. So there's one on the next page that I want y'all to try. Determine if these two lines are parallel, perpendicular, or neither. Go ahead and pause the video, work it out, and when you're ready to check yourself, or if you get stuck, play the video and we'll go over it. All right, so when we look at the top line, when we get it completely solved for y, we should get y equals negative 1/2 x minus 3/2, meaning its slope is negative 1/2, right? When we solve the second line for y, we move our 2x to the other side and then divide off our 4, which notice here, that's going to reduce and give us a slope of negative 1/2 also. So because the slopes are the same, that means that these two lines are parallel. Okay? All right, so now let's talk about how we're going to use this. So before, when we were finding the equation of a line, they either gave us the slope or they gave us 2 points and we had to find the slope, right? Now, instead of them giving us 2 points, they're just going to say, hey, our line goes through this point, but it's parallel to this other line. So if my line is parallel to this other line, then that means our slopes are the same, right? If my line is perpendicular to that line, I can just figure out what's the slope of that line and then take the opposite reciprocal to use for my line. Okay, so that's what we're going to do. So let's look at this one at the bottom of the page. It says, write a slope-intercept equation. That means we want something that looks like y equals mx plus b for a line passing through the given point that is parallel to the given line. Okay. Then write a second equation for a line passing through the given point that is perpendicular to the given line. So on this one, it's going to have us find both lines. In your homework, it's probably only going to ask you for one. So make sure you pay attention to whether it's asking for parallel or perpendicular. That way you know whether you're using the same slope or the opposite reciprocal slope. Okay. So either way, I first need to figure out what is the slope of this line so I can figure out what the slope of my line is going to be. So I need to solve this for y. So I'm going to subtract 3x from both sides. So I end up with 4y is equal to negative 3x plus 5. And then I divide off the 4. So that gives me y is equal to negative 3/4 x plus 5/4. So I can see the slope of this line is negative 3/4. So that means any line parallel to this line should have the same slope. So if we're looking for a parallel line, our slope is also going to be 3/4. Okay? But if we're looking for a perpendicular line, then we would take the opposite reciprocal. So instead of negative, it's going to be positive. And then when I flip it, that's going to be a positive 4/3. Okay? So I have all the information I need. Now I just need to find the parallel line and the perpendicular. Okay? So for parallel, I'm going to use the parallel slope, which is negative 3/4, and I'm going to use the point that was given, which was 3, 2. Okay, so now I'm going to plug it into my y minus y1 is equal to m times x minus x1. So I do y minus the y that was given in the point, which is 2, is equal to my slope, which we just determined is negative 3/4 because it's the same as the line given, times x minus the x given in the point, which is 3. Okay, and now I just need to simplify. So I have y minus 2 is equal to, when I distribute here, I get negative 3/4 x. When I distribute here, you can think of this as 3/1, right? We multiply fractions, we multiply tops with tops, bottoms with bottoms. So negative 3 times negative 3 gives me a positive 9 on top, and on bottom 4 times 1 gives me a 4 on bottom. Okay, and then the last thing I need to do is move my 2 to the other side. So I'm going to add 2 to both sides. But notice when I go to add 2 over here, I can't add 2 and 9/4 because they don't have the same denominator, right? 2 is a whole number, so its denominator right now is over 1. So if I want to combine these, I need them to have the same denominator. And the least common denominator between the two would be 4, right? So if I want to write 2/1 as something over 4, I would have to multiply on top and bottom by 4, right? So I can say this is the same thing as a positive 8/4. You agree, right? Because if I were to reduce 8/4, I would get back to 2. All right, so I'm just going to mark this out because now I've rewritten it as 8/4. So now I have y is equal to my slope, negative 3/4 x. And then when I combine the 9/4 with the 8/4, that gives me a positive 17/4. So this is the line that goes through the given point that is parallel to the line given. Okay. Now let's find the perpendicular line. For the perpendicular line, I need to use the perpendicular slope. So my perpendicular slope is 4/3. And again, I'm using the point given, which was 3, 2. And then I'm going to plug it into the same equation that I had above, right? Y minus y1 is equal to m times x minus x1. So I do y minus the y of my point, which is 2. And that's equal to my slope, which I know in this case, because it's perpendicular, is a positive 4/3 times x minus the x of this point, which is 3. Okay. All right. So now I just need to distribute my 4/3. So I have y minus 2 is equal to 4/3 x. When I distribute 4/3 to the 3, I can think of this as 3/1. So 4 times 3 gives me the negative 12 on top, and 3 times 1 gives me 3 on bottom, right? And then this reduces, right? Negative 12/3 is the same thing as what? Negative 4, right? So I'm just going to write over here, this is negative 4, and I'm going to mark that out just because I'm running out of room. And then I need to move my 2 over. So I add 2. So I end up with y is equal to 4/3 x, and then my negative 4 plus 2 leaves me with a negative 2. So this is the equation of the line that's perpendicular to the given line and going through the given point, right? And you can always double check at the end. The parallel line should still have the parallel slope, which is -3/4. The perpendicular line should have the perpendicular slope, which is +4/3. Okay. All right, so there's one for y'all to try on the next page. Once you've done that one and you're ready to be checked, go ahead and unpause the video and we will go over it and see how you did. All right, so the first thing we want to do is take the given line and solve it for y. When we do that, we end up with y is equal to -2x minus 4. So we can see here that our slope is going to be -2. So for any line that's parallel to this line, our slope is going to be -2. For any line that's perpendicular to it, we need to flip it and change the sign, which would give us a +1/2. Okay, so now, I'm just going to scoot this up. So now that we know the slope for parallel, which is -2, and the slope for perpendicular, which is +1/2, we're using those slope along with the given point to find the equations of the line. So on the first one, we should have y minus a -5 is equal to -2 times x minus a -4. Our double negatives become positive. Then we distribute the -2 and move our 5 to the other side. So your parallel line should be y equals -2x minus 13. For your perpendicular line, again, y minus the -5 that was given is equal to your perpendicular slope 1/2 times x minus your -4 that was given. Double negatives make those positive. We distribute the 1/2 and then we move the 5 over, which should give us a perpendicular line of y equals 1/2 x minus 3. Okay, so that is the end of section 1.4. You should now be able to do the My Math Lab assignment. There is also a worksheet that goes with section 1.4. So make sure you complete that assignment as well. If you have any questions, let me know.